So imagine your town approves this $30 billion state-of-the-art international airport right in your backyard.
Oh, wow.
Right. I mean, we're talking massive runways, gleaming terminals, just the works.
Huge economic driver, theoretically.
Theoretically, exactly. But then on opening day, you find out that, like, only 100 people from your town are actually getting jobs there.
Right.
And on top of that, they're mostly going to be working as, security guards or janitors. You would be furious, right? The math just feels completely broken.
It is a massive disconnect.
Yeah.
I mean, people look at the sheer scale of the concrete being poured,
Yeah.
and they naturally expect this proportional wave of local employment.
Yeah, of course they do.
And when that doesn't happen, well, the confusion turns into anger very quickly.
And honestly, that invisible collision between physical concrete and digital jobs, that is our mission for this deep dive. Today, we are exploring the massive hidden gap between the physical AI infrastructure we're building and the workforce required to actually make it useful.
Such a critical gap, too.
It really is, and we're using a super timely source for this. It's an August 2026 policy analysis by Dr. Todd Mann, and it's called The Digital Power Plant Paradox.
Yeah, that paper is fascinating.
It drops us right into the middle of this real-time policy crisis that's happening literally as we speak in July 2026 down in the state of Georgia.
And Georgia's is just the perfect laboratory for this. I mean, they are attempting something that almost no other state really has the appetite for right now.
Right?
They're building out enormous multi-gigawatt computing power while at the exact same time trying to completely overhaul their workforce governance structure.
Which is incredibly ambitious. Let me put some numbers to this so you listening right now can picture the sheer scale of what's happening. Currently, Georgia has over 150 active data center facilities.
150.
Yeah, and they recently approved a 10-gigawatt grid expansion, which is heavily anchored by the nuclear baseload coming from Plant Vogtle. But like the absolute crown jewel of this entire build-out is OpenAI's project Camellia in Effingham County.
Oh yeah, the scale of Camellia is just staggering.
We are talking about a capital commitment of between $20 and $30 billion. It sits on a 1,400-acre campus.
Wow.
And get this, it requires a 3.2 gigawatt power commitment for the next 25 years.
Just to contextualize the 3.2 gigawatts for a second, that is roughly the power consumption of a major American city.
A whole city.
A whole city, yeah, dedicated to a single corporate campus. I mean, it's an infrastructure investment on a scale we really haven't seen since, like, the construction of the interstate highway system.
So, look, whether you are, prepping for a tech sector strategy meeting or you're tracking where the AI economy is heading, or even if you're simply curious about where the promised jobs of the future are actually hiding, consider this analysis your ultimate cheat sheet.
Definitely.
Because we are going to figure out how this localized AI economy actually translates into real wages.
Because if we look at what is happening on the ground in Effingham County right now, that translation is, well, it's completely failing.
Yeah, let's get right into that political firestorm because it really illustrates the problem perfectly. Back in July 2026, so just recently, a massive conflict erupted over Project Camellia.
Right, the open house.
Exactly. So the local industrial development authority in Effingham, they approved the project along with this massive 15-year, 50% property tax abatement. And it kind of happened quietly.
Very quietly.
But when they finally held a public open house, nearly 1,000 residents showed up, and the backlash was fierce. The core issue driving all this anger was that a $20 billion facility was only projected to create a few hundred to maybe 1,000 permanent on-site jobs.
And, looking at the facts impartially here, without taking a side, you basically have two clashing perspectives. On one hand, you have the county officials. They actually admitted they withheld the written proposal from public discussion for months.
Which obviously doesn't look great.
No, it doesn't. But their stated reasoning was that they didn't want to deter a massive, unprecedented corporate investment by subjecting it to, premature public scrutiny before the ink was dry.
Right, but then on the other side, the residents felt a project of this magnitude was just being shoved down their throats without any democratic fairness.
Exactly.
They're looking at the footprint, they're looking at the massive power usage and the tax breaks, and they are understandably asking, wait, where is the economic opportunity for our families?
Right. And to be fair, OpenAI did step in later and make public commitments that residential power rates would not go up because of their massive draw.
Yeah, they promised to bear the full cost of the infrastructure upgrades, I think.
They did. But by the time they communicated that, the public trust was already pretty fractured.
Okay, let's unpack this.
Yeah.
Because it really is just like dropping a massive state-of-the-art airport in a small town, but telling the residents that only 100 people will get jobs there, and they're mostly going to be security guards. You can see why they're so angry.
What's fascinating here is that Dr. Mann's paper uses the Sinafin sense-making framework to explain this exact dynamic. He specifically points to what's called the disorder trap.
Wait, the Sinafin framework, I'm not familiar with that. How does it define disorder? Because usually, disorder just means I haven't cleaned my office in a week.
Right, right. Well, in the Sinafin framework, it's much more specific. It categorizes problems based on cause and effect. So disorder is actually a specific diagnostic failure state.
Okay, how so?
It happens when decision makers don't actually understand what kind of system they are operating in. So they default to the metrics they are most comfortable with, even if those metrics are completely inappropriate for the new situation.
Ah, I see. So it would be like trying to figure out how fast a car is moving by, I don't know, checking the tire pressure. Like you're using a valid measurement tool, but it's answering a completely irrelevant question.
Precisely. Judging a 2026 AI data center by its direct on-site headcount is a classic disorder trap. The public is applying a manufacturing era metric to an entirely new asset class.
Because in the past, big footprint meant big headcount. Exactly.
In the 1950s, if you built a massive auto plant, the economic value was the thousands of factory workers clocking in every morning.
Mm.
But a data center doesn't manufacture physical goods. It processes information.
Right.
So the math the residents in Effingham County are doing isn't mathematically incorrect. It's just being applied to the wrong era of infrastructure.
And this isn't just a localized PR problem in one county either. The paper points out that this specific mismeasurement demanding permanent on-site jobs from data centers has stalled or completely blocked over 75 massive infrastructure projects.
Yep.
We're talking projects worth $130 billion across 49 states, just in the first quarter of 2026 alone.
It is a national bottleneck. Honestly, if we keep measuring AI infrastructure by the number of people walking through the front gate, we will completely freeze our national compute capacity.
Okay, so if counting the people on site is the wrong way to measure the economic value, where's the value actually landing? Because I imagine that $20 billion isn't just, evaporating into the cloud.
No, it's not.
Which leads to a massive conceptual shift in this paper. The author argues we need to stop thinking of these facilities as just data centers and start thinking of them as digital power plants.
Yes, this is the linchpin of the whole analysis. The compute power generated inside those chain link fences is not where the jobs are. The value behaves much more like a utility.
Like the electrical grid.
Exactly. A traditional power plant generates electricity that travels down the lines to power factories and businesses miles away, right? Well, a digital power plant generates computing capability that ripples outward. It creates downstream productivity for businesses and workers in all the surrounding regions.
I am trying to visualize this practically, though. I understand how a power plant gives electricity to a local factory so they can run the assembly line, but how does a server farm actually help an everyday worker out in the community?
Right.
Like, how does this compute power assist, say, an HVAC technician or a local electrician?
To unpack that mechanism, Dr. Mann uses McKinsey's 3 waves of AI value, and he applies them directly to Georgia's high-demand career list. It's really helpful to look at these waves as different depths of economic impact.
Okay, so what's the first wave?
Wave 1 is productivity acceleration. This is the most basic level. Imagine a medical record specialist. They use the local compute power to instantly transcribe and format patient histories. It's a pure speed improvement on a highly routine task.
So they're basically doing the exact same job they've always done, they're just doing it a lot faster.
Yes, and frankly, Wave 1 is quickly becoming the baseline just to stay employable. It doesn't command a massive wage premium because it's so easily replicated. But Wave 2 is where the real economic value sits. This is workflow differentiation. It relies on a biological concept called exaptation.
Wait, exaptation? I think I remember that from evolutionary biology. It's when an organism uses a physical trait for a completely new, unintended purpose, right?
Yeah.
Like dinosaur feathers originally evolving for warmth but eventually being used for flight.
That is the exact mechanism, just apply to human skills in the workforce. In Wave 2, a worker repurposes their existing domain expertise by augmenting it with that local low-latency compute power.
Okay, can you give me an example?
Let's take your electrician example from earlier. That electrician does not need to learn how to write Python code.
Right.
Instead, they use AI to instantly cross-reference a highly complex, non-standard wiring job against the National Electrical Code. Or they use it to run complex thermal load calculations in 3 seconds instead of 3 hours.
Wait, let me test this out on another industry just to see if I am grasping the exaptation concept.
Go for it.
What about like a logistics manager at the Port of Savannah? Wave one would be them using AI to just, write their daily shift reports faster.
Routine speed.
But wave two, exaptation, would be them using their deep knowledge of supply chains, combined with AI, to instantly model out 5 different rerouting scenarios when a cargo ship gets delayed by a storm, allowing them to make a high-level strategic decision in minutes.
You have it perfectly. Their core expertise, knowing how the port actually operates, that remains the foundation. But their productivity ceiling just completely shatters because the AI handles the heavy cognitive lifting of the calculations.
That makes total sense.
And this is exactly where state training dollars yield the absolute highest wage premium. An individual worker's professional judgment becomes hyper-leveraged by the digital power plant in their backyard.
But then the paper moves into wave three, and this is where the tone shifts significantly. Wave three is transaction cost reduction.
Which is really just a polite economic term for structural disruption.
Uh-oh.
Yeah. This wave impacts roles that are built heavily on coordination and friction. Think about a mid-level sales representative or certain travel concierge role.
Roles that act as middlemen.
Exactly. Their daily routine involves a lot of scheduling, initial discovery calls, managing communications. AI agents are becoming incredibly adept at taking over those friction-heavy tasks entirely.
So for a wave three worker, the AI isn't an exoskeleton making them stronger. It's an alternative to them entirely.
Well, the human role doesn't necessarily disappear entirely, but it migrates far upstream. The human is only needed for the final, highly complex relationship management, we're actually closing the deal.
So they need a different kind of help.
Right. For a lot of workers in Wave 3, a standard AI upskilling class isn't going to save them. They need serious transition planning because the core mechanics of their job are basically being automated away.
So the mandate for a state like Georgia is super clear. They need to move as many workers as possible into that sweet spot of wave 2 exaptation.
Yes.
But how does a state actually train tens of thousands of people for that in real time? That brings us to Georgia's brand new statutory gamble. House Bill 1302, which is also known as Act 474, it just took effect a few weeks ago on July 1st, 2026.
It's a fascinating piece of legislation because it attempts to forcibly rewire how the state government functions. Previously, workforce development was heavily siloed.
Oh, I'm sure.
Act 474 consolidates all those fragmented agencies into one central hub, the Governor's Office of Education and Workforce Strategy, or GOEWS.
It also designates the technical college system of Georgia as the sole authority for apprenticeships. And perhaps most importantly, it establishes an education data governance board to oversee everything.
Right.
So instead of 5 different agencies guessing what the others are doing, one board tracks the training plan, the apprenticeship pipeline, and the actual wage outcomes all at the exact same time.
That is the architectural intent, yes.
Here's where it gets really interesting, though. I am going to push back on this.
Okay, let's hear it.
Moving government acronyms around on a whiteboard in Atlanta does not automatically train a pipe fitter down in Rincon, Georgia. State IT systems are famously slow. They are bogged down by privacy laws like FERPA for student data and HIPAA for medical data, and they rarely communicate well with each other. Isn't there a massive execution risk here? It feels like we are assuming a level of bureaucratic competence that rarely exists in practice.
If we connect this to the bigger picture, your skepticism is entirely validated by Dr. Mann's analysis. He explicitly warns about what he calls the legacy badge problem.
The legacy badge problem.
Right. To understand the danger here, we have to look back at the Sweet v. Cardona federal settlement regarding for-profit colleges.
Oh, right, the massive student loan forgiveness case.
Yes. For years, several for-profit campuses in Georgia, like Westwood College and ITT Tech, were able to self-report incredibly inflated job placement numbers. The state's accountability apparatus was essentially passive.
Meaning they just took their word for it.
Basically, it relied on the institutions handing over a spreadsheet of their own success. The state couldn't independently verify if a student who got a certificate actually went on to earn a higher wage in that specific field.
It is like a university printing its own currency and then grading its own economic exams. If the state doesn't have an independent, hard data way to verify the value of those degrees, the credential, the badge, is basically worthless.
That is the legacy badge problem in a nutshell. If this new Education Data Governance Board cannot function flawlessly, if it cannot securely link student training data across state IT systems to real longitudinal wage outcomes at the Department of Labor, then Georgia risks repeating the exact same audit failures.
Because if they can't mathematically prove that a worker who took an AI course actually saw their paycheck increase, then telling the residents of Effingham County that the data center is a digital power plant for their benefit just sounds like empty political spin.
Exactly. The policy is only as strong as the data pipeline verifying it.
Which brings us to the actual classroom level. Let's say the governance board works perfectly. What exactly should the state be teaching these workers?
That's the million-dollar question.
Because Dr. Mann outlines a major trap here called the ephemerality trap. If a technical college spends 6 months developing a curriculum on how to use a specific AI interface, by the time the worker graduates, the software model has updated 3 times and the interface is completely different.
It is a curriculum nightmare. The value of the credential depreciates based on a Silicon Valley vendor's software release schedule, completely ignoring the worker's long-term career timeline.
That sounds incredibly frustrating for the student.
Oh, it is. You cannot teach software mechanics. You have to teach underlying cognitive frameworks.
And that is where the 4 literacy specification comes in. The paper argues that these 4 cognitive skills must form the foundation of any training, making the worker adaptable regardless of what software they're using today or tomorrow. Let's walk through these because they completely reframe how we think about interacting with machines.
Absolutely. The first literacy is linguistic precision. It is far beyond just, typing a question into a chat box.
Right.
It is the ability to give an AI system an unambiguous, highly bounded set of instructions. If an HVAC technician asks a diagnostic AI a vague question about a compressor, the AI will likely return a highly plausible-sounding but technically incorrect answer.
Basically hallucinating.
Yes. The worker must know how to precisely define the constraints of their prompt to prevent that.
Which naturally leads into the second literacy, critical thinking. The paper defines this as treating AI output as a claim to be rigorously tested, not a conclusion to be blindly accepted. If you assume the machine is an oracle, you will eventually install the wrong wire or order the wrong part.
Which brings us to the third literacy, systems thinking. This is crucial for avoiding the isolation trap.
The isolation trap.
Yeah. A worker might use AI to completely streamline and speed up step 1 of their daily workflow. But if they don't possess systems thinking, they might not realize that moving 3 times faster on step 1 completely overwhelms step 3 down the line, breaking the entire operational chain.
I can easily see that happening. You use AI to approve vendor contracts in 10 minutes instead of 10 days, but you completely crash the accounting department who now has to process 100 payments at once.
Precisely. You have to understand how your accelerated output impacts the broader ecosystem. And finally, there's metacognitive awareness.
Okay, what does that one mean in practice?
This is the capacity for a worker to monitor their own thought processes in real time. They need to notice when they are mentally fatigued and might be tempted to just substitute the AI's rapid output for their own professional judgment.
It's basically teaching people how to think in tandem with a machine, maintaining their own cognitive sovereignty rather than just becoming a lazy button pusher.
Beautifully said. And these 4 literacies are what unlock the TPEC-3 cohesive ROI model.
Okay, I found this model fascinating, but the acronym is a bit dense. Walk me through what TPEC-3 actually stands for and how the mechanism works in a real business environment.
Sure. TPEC-3 maps the journey from technology adoption to actual economic value. It stands for time, productivity, efficiency, conversion, cash, and capabilities.
Okay, that's a lot of C's.
Right, it is. But the core mechanism is this. AI initially saves worker time, but time saved is meaningless if it isn't converted into actual productivity and efficiency.
Because you could just use that saved time to scroll social media.
Exactly. And even then, a business only benefits if they achieve conversion, turning that efficiency into actual cash flow.
So simply finishing a task early doesn't equal cash unless the business captures that time and redirects it towards something profitable.
Exactly. And the final C, capabilities, is the linchpin. The time saved by AI only converts to cash if the human worker possesses the critical thinking capabilities to avoid those costly downstream errors we talked about. Compute power only compounds if human capability compounds alongside it.
So what does this all mean? I am looking at all of this, the potential of Wave 2 exaptation, the four literacies, the TPEC 3 model, and it sounds incredible.
It is.
But if I am a resident in Savannah right now and I want to go get this kind of deep cognitive AI training, what is stopping me? Why is it so hard to actually get enrolled?
This is where we hit the really painful reality of frontline workforce funding.
Hmm.
The irony is the money to pay for this training already exists.
It does.
Yes. It's available to the worker for free through a variety of streams. Federal WIOA accounts designed for workforce retraining, state-level HOPE career grants, and federal Perkins funding for technical education.
Wait, if the money is sitting right there, why aren't local case managers distributing it to the workers who want to upskill?
Because of a structural mechanism the paper calls audit panic.
No.
The state policy highly encourages what is known as braided funding.
Braided funding with.
This means a local case manager takes a little bit of federal WIOA money, combines it with state HOPE grant money, and maybe adds some Perkins funds, all to fully cover one student's tuition and living expenses.
I mean, that sounds incredibly efficient on paper.
On paper, yes, it's brilliant, but in practice, it is a compliance nightmare.
Why?
Every single one of those funding dollars comes with a different master. Federal WIOA funds require one set of rigorous compliance metrics and eligibility proofs. State HOPE grants require a completely different set of paperwork. Perkins requires a third. When a local case manager, who is already overworked, tries to braid these funds together for a single student, they multiply their audit exposure exponentially.
I see. So if they make one clerical error on a form, they risk failing a massive federal or state audit, which could jeopardize their entire department's funding or even their own job.
Exactly. The risk mechanism is entirely skewed against action. So rationally, the case manager engages in audit panic. They choose to only use one single funding stream because it's safer.
Which leaves thousands of dollars on the table.
Yes, and the worker doesn't get the full funding they need to complete the intensive training. It is a tooling gap, not a lack of resources.
So how do we fix that?
Dr. Mann strongly recommends that the Georgia General Assembly step in and create a free-approved, standardized documentation template that satisfies all the different agencies at once. If the state absorbs the compliance risk, the local case managers will finally feel safe enough to deploy the funds.
Man, we have covered a tremendous amount of ground here, so let's pull it all back to the big picture. Georgia has essentially initiated a massive 12 to 24-month stress test for itself. They have successfully built the physical infrastructure, the 10-gigawatt grid, the 150 data centers, and the staggering $20 billion footprint of Project Camellia.
Yep.
And as of July 1st, with Act 474, they have built the statutory policy infrastructure to match it.
But the clock is absolutely ticking. Over the next year or two, the Education Data Governance Board has to prove that the system works. They have to produce verifiable, cross-reference data proving that a local worker in Effingham County took an AI upskilling course, successfully applied the 4 literacies, and demonstrably increased their take-home pay.
Because if they can't point to real, tangible wage outcomes for local families before the next multi-billion-dollar data center is announced, the narrative that these facilities are digital power plants is going to fail in the court of public opinion.
Completely fail.
And the entire infrastructure build-out could freeze.
The stakes for the state's economic future, honestly, could not be higher.
As we wrap up, I want to turn this directly to you, the listener. Think about your own day-to-day workflow. Which wave are you currently riding? Are you stuck in wave 1 just using tools to type emails faster? Or are you actively finding ways into wave 2, utilizing exaptation to hyper-leverage your unique industry expertise?
This raises an important question. Are you just memorizing how to click buttons on today's software? Or are you cultivating the linguistic precision and systems thinking that will make you indispensable no matter what technology arrives tomorrow?
Because developing those underlying literacies is the only difference between being replaced by the new infrastructure and learning how to build a career on top of it.
Well said.
I want to leave you with one final, slightly provocative thought to mull over. We didn't explicitly cover this in the text, but it is the logical endpoint of everything we've discussed today.
That should be good.
If we truly are reframing these hyperscale data centers as digital power plants, meaning we accept that compute power is a foundational essential utility, just like our municipal water systems or our electricity grids, does that mean they should eventually be regulated as public utilities?
Wow.
Right. As these facilities consume massive amounts of our local land and power, should there be guaranteed public access or democratic oversight over the compute power they generate in our own backyards?
That is a deeply complex question that policymakers will inevitably have to face as this infrastructure expands.
It is definitely something to think about the next time you see a massive construction site on the edge of town. Thanks for joining us on this Dick Dive. Keep questioning the systems and the information around you, and we will catch you on the next one.